Okay, so are you ready to get kind of theoretical?
Always.
We've gotten a lot of requests to do a deep dive on the work of Leonard Susskind, and I have to say it's been a really fascinating journey so far, just in the
Cool.
prep.
Oh, absolutely.
You sent in an article, you know, outlining some of his achievements, and then
Certain
also,
criticisms.
yeah. So we want to make sure we tackled all of that because it seems like a really interesting story.
A very complex figure.
Yeah, so how about this for an intro to the deep dive?
Mm-hmm.
The idea that our 3D reality is basically like a projection from a 2D surface.
Yeah, and it's not even that far out there of an idea when you really start to think about it.
Yeah. And, we're going to be talking about the holographic principle and black hole complementarity,
Yeah.
all these things that Susskind is really, really famous for.
Yeah, and even beyond those two things, he's done so much work in string theory, quantum mechanics, just a really foundational figure in theoretical physics.
Yeah. And also a really big name in pop
Oh,
science.
huge, right?
So he's able to kind of, do the really hard science, but then also explain it in a way that everyone can at least try to grasp.
Absolutely. And that's a really special skill because, like, when you think about these concepts,
They're so complex.
like explaining it to, even another physicist can be difficult, let alone, someone that doesn't have that background.
Yeah, definitely. So you mentioned that you're really interested in his work with black holes, so maybe we could start there.
Yeah, let's do it.
So this idea of the holographic principle, what is that even like? I mean, I keep hearing it's like from a sci-fi movie, like we're just projections, like what's going on?
Well, it kind of is like a sci-fi movie, to be honest with you. And I think that's what's so fascinating about it. And that's kind of what draws people in. But Suskind, he kind of uses this analogy of a movie projector.
Okay,
So, you think about a movie playing in a theater and everyone's watching this projection on the screen.
right.
But what if I told you that that projector wasn't actually in the middle of the theater? It was off, on some distant screen somewhere else.
Mhm.
And so what we're seeing is just this projection, but the real action is happening somewhere else entirely.
So you're saying like we're not living in a simulation, but that all the information that makes up our reality, our 3D universe,
Exactly.
is actually encoded on a 2D surface, like at the edge of the universe.
Yeah, and so like think of it as like, one of those giant puzzles where the solution is not in the middle of the puzzle, it's all around the outer edge.
Right.
And you have to look at that edge to kind of understand what's happening in the middle.
Okay, so it's like we're just seeing the puzzle, but the answers are somewhere else.
Precisely. And the thing is, we can't, like, break out of the puzzle. We're kind of stuck in it. But we can try to understand that edge. And that's kind of what a lot of theoretical physics is trying to do now, is to understand that boundary. And maybe that's the key to, like, unlocking all these secrets of the cosmos.
Well, it's definitely a lot to wrap your head around, and it kind of makes you question, like,
Yeah.
okay, if that's the case, what does it even mean to be real?
Yeah.
What is reality?
Well, that's a great question. And I think,
It's a big one, right?
yeah, and that kind of leads us to Suskind's work on black holes and something called black hole complementarity.
Right. And, we have to talk about the information paradox
Oh, absolutely.
because that's kind of like the central problem here, right? Like, what happens to information when it falls into a black hole? Does it just disappear?
Well, that's what we thought for a long time because, the event horizon of a black hole, you can think of it as the point of no return.
Right.
Once you cross it, there's no coming back. And that's where things get a little sticky with quantum mechanics.
Okay.
Because quantum mechanics states that information can't be destroyed, but then here come these black holes just gobbling it up, seemingly.
So wait, so you're saying that all the information that's ever fallen into a black hole, it's still there?
It's still there on the event horizon.
So it's like we could read the history of everything that's ever fallen in if we could just get to that event horizon.
Well, in theory, yes, the information's all there. It's like a cosmic hard drive storing all the secrets of everything that the black hole has ever consumed. But accessing that information is a completely different beast altogether.
Right. Yeah.
We're not quite there yet technologically.
Okay, so Susskind with black hole complementarity, he's saying that the information isn't destroyed, it's just kind of stuck on the event horizon.
Exactly. It's preserved. It doesn't just vanish. And that's how he reconciles this, seemingly conflicting idea between general relativity and quantum mechanics.
Okay, and this idea about information being preserved, it also leads us to Suskind's influence on string theory, right? Specifically with something called the eta-CFT correspondence.
Oh, yes, absolutely.
Okay, so break that down for us.
Okay, so this is going to be a little out there, but imagine two different universes, one with gravity, one without.
Okay.
And the ATA-CFT correspondence, which actually Suskind's protege Juan Maldacena really fleshed out, suggests that these two universes are actually two sides of the same coin. They're linked in a way that we're only just beginning to understand.
So it's like two completely different universes, but they're somehow connected.
Yeah, it's kind of like finding a secret passage between, these two seemingly separate worlds.
That's wild.
It is. It really is.
Okay, so we've been talking a lot about Suskind's genius and his impact, but we can't ignore that there's also been some pushback to his ideas.
Right.
The article you sent mentions some pretty serious criticisms from Eric Weinstein.
Yes, and Weinstein is no slouch himself. He's a very accomplished mathematician and physicist.
Yeah.
And his main argument is that Susskind has become a bit too dominant in the field and that he's kind of stifling alternative approaches to physics.
So he's saying that Susskind is kind of like the gatekeeper of theoretical physics.
In a way, yes. And it's an interesting argument because, on one hand, we want to celebrate these giants of science, but on the other hand, we also need to make sure that there's room for new ideas and new voices.
Right. And Weinstein, he actually proposes this idea of like a new Shelter Island conference.
Yes. That's a fascinating proposition.
Kind of inspired by the original Shelter Island meetings, where like all the big physicists got together back in the 40s.
Yeah, and they made some incredible breakthroughs.
Yeah, it was like a really pivotal moment in the history of physics.
Yeah, it was. And so Weinstein is suggesting we need something like that again to bring together all these different minds, maybe some people who disagree with Susskind even.
Right, to just get the conversation going again.
Exactly, maybe hash some things out.
Yeah.
Who knows what could come out of that?
Well, it's definitely food for thought, and regardless of all these controversies, I think we can all agree that Suskind's impact on physics is undeniable, especially when you consider his work as a teacher and mentor.
Oh, absolutely. His lectures are legendary. You can find them online. They're engaging, they're funny, they're informative, and he's really inspired, countless students to pursue careers in physics.
Yeah, and he's also written some really popular books, too.
Oh, yeah, like The Black Hole War
Yeah.
and The Theoretical Minimum. These are books that, anyone can pick up and learn something from.
Yeah, and they're not just like dumbed down physics either. He really gets into the weeds, but in a way that's still accessible.
Yeah, he does a great job of walking that tightrope between rigor and accessibility.
Exactly. Well, we've covered a lot of ground today. We've explored Suskind's genius, his impact, and also some of the criticisms surrounding him.
He's been a journey.
It has, and it's clear that he's a really complex figure,
Oh, absolutely.
both brilliant and controversial. But what do you think? What does this deep dive tell you about the interplay of personality, collaboration, and progress in science?
Well, I think it shows that science is a human endeavor, and it's driven by people with passions and with flaws. And sometimes those things clash, and sometimes those things create beautiful things.
Yeah, it makes you wonder if someone like Susskind could have achieved what he did without being such a strong personality, without maybe ruffling some feathers along the way.
It's hard to say, but it's a fascinating question.
It is. And if you want to delve even deeper into the mind of Leonard Susskind, we highly recommend his books, The Black Hole War, The Theoretical Minimum series.
Yeah, they're a great starting point.
Yeah, they're a great way to explore the universe through the eyes of a truly remarkable and sometimes controversial physicist.
Couldn't have said it better myself.
Thanks for joining us on this deep dive, and we'll see you next time.
See you later.
Bye.
Bye.